Now we will start with 3.2 compounds of boron. Borax is sodium tetraborate 3.2.1 Na2B4O7.10H2. Borax is the sodium salt of tetraboric acid and it is the most important of all the borates. Occurrence is borax occurs as a natural deposit called tincal in the dried up lakes of Tibet and California. Manufacture number 1. Formerly borax was manufactured by treating a hot solution of boric acid with the proper amount of soda ash. 4H3BO3 plus Na2CO3 gives us Na2B4O7 plus 6H2O plus 6CO2. 2. Nowadays, borax is almost exclusively obtained from calcium borate. Finely powdered coal mannite is boiled with Na2CO3 solution while CaCO3 precipitates out and a mixture of borax and sodium metaborate is formed. Ca2B6O11 plus 2Na2CO3 gives us 2CaCO3 plus Na2B4O7 plus 2NaBO2. The clear solution from the top is taken off and is then allowed to crystallize. When crystals of borax separate out to get more borax, CO2 is blown through the mother liquor. The sodium metaborate is decomposed into borax which separates out in the form of fine crystals. 4NaBO2 plus CO2 gives us Na2CO3 plus Na2B4O7. Number 3. Borax may also be obtained from tincal by treating tincal with water and subsequently evaporating the clear solution when crystals of borax separate out. Properties. Number 1. Borax is a white crystalline solid. It is sparingly soluble in cold water but is more soluble in hot water. 100 grams of water dissolve 3 grams of decahydrite at 10 degrees Celsius and 99.3 grams at 100 degrees Celsius. If a saturated solution be allowed to crystallize above 62 degrees Celsius, octahedral crystals of pentahydrate Na2B4O7.5H2 separate out. If the temperature is below 62 degrees Celsius, the decahydrate is formed. Its aqueous solution is alkaline in nature due to hydrolysis. Na2B4O7 plus 7H2O gives us 2NaOH plus 4H3BO3. The hydrolysis is prevented in the presence of glycerin. When heated, borax loses water and swells up into a white porous mass due to the expulsion of water. On further heating, it melts into a clear transparent glass which dissolves many metallic oxides, forming colored beads. This reaction forms the basis of borax bread test. Na2B4O7.10H2O gives us Na2B4O7 plus 2NaBO2 plus B2O3. Its aqueous solution reacts with HCl or H2SO4 to form boric acid. Na2B4O7 plus 2HCl plus 5H2O gives us 2NaCl plus 4H3BO3. Na2B4O7 plus H2SO4 plus 5H2O gives us Na2SO4 plus 4H3BO3. When borax is heated with aluminum chloride, boron nitride is produced. Na2B4O7 2NO4NH4Cl gives us 2NaCl plus 2Bn plus B2SO3 plus 4H2. And borax when dissolved in water ionizes as Na2B4O7 gives us 2Na plus B4O7 2 minus. Hydrolysis of B4O7-2 occurs as follows: B4O7 2 minus plus 7H2O gives us 4H3BO3 plus 2OH minus. So a strong alkali NaOH is formed which is highly ionized, and on the other hand boric acid H3BO3 is ionized to a little extent because it is a weak acid. Hence, solution of borax as a whole is alkaline in nature. Number 6. Borax bread test. To prepare a loop at the end of a platinum wire, heat the wire and take a little powdered borax on the hot loop. Heat again, borax first swells up and then melts into colorless glass-like bead on the loop. Now put a few grains of the substance under examination on the beads and reheat it first in the oxidizing flame and then in the reducing flame. Chemistry of the borax bead test. Borax when fused is decomposed into sodium metaborate and boric anhydride Na2B4O7, 2NaBO2 plus B2O3. The metallic oxide formed from the substance under examination combines with B2O3, giving the colored metallic borates. With cupric oxide, the beads are colored blue in the oxidizing flame because cupric borates are blue in color. CuO plus B2O3 gives us CuBO2 whole 2. Uses of borax. It is number one used to prepare borate glass, which is heat resistance. Number two, it is used in softening of water. Number three, it is employed in borax bead test for the detection of metallic cations. Number four, it is used in metallurgical operations. Number five, it is used as a flux in welding and in metallurgy. It is employed in making washing powders. Number seven, it is used in leather industry for tanning and dyeing. Number eight, it is used in cosmetics, soap, textiles, paints, medicine, match industry, and as a preservative.